Every password you've ever created, every bank transaction, every encrypted message, every government secret, a quantum computer could crack all of it in seconds. Not in science fiction, not in 100 years. The world's biggest tech companies are building this right now. And some experts say we have less than a decade before the internet as we know it breaks. So, what exactly is quantum computing? Why is it so dangerous? And what happens when it arrives? To understand quantum computing, you first need to understand why regular computers have limits. Every computer you've ever used, your phone, your laptop, the servers running the internet, works with bits. A bit is the simplest unit of information. It's either a 0 or a 1, off or on. Nothing else. Everything your computer does, every video, every email, every game, is just billions of zeros and ones being flipped incredibly fast. This works brilliantly for most tasks. But some problems are so complex that even the fastest classical computer would take longer than the age of the universe to solve them. Here's a simple example. Imagine you're trying to find the right key from a keyring with a billion keys. A classical computer tries them one by one. Even at 1,000,000 keys per second, that's 1,000 seconds. Now, scale that up. A keyring with more keys than atoms in the observable universe. That's the kind of problem modern encryption is built on. And that's exactly why your bank account is safe. For now. Quantum computing throws out the rulebook entirely. Instead of bits, quantum computers use qubits. And a qubit doesn't have to be a 0 or a 1, it can be both at the same time. This sounds impossible, but it's not magic, it's physics. At the quantum level, the level of individual electrons and photons, particles don't behave like objects we can see. They exist in a fuzzy cloud of possibilities called superposition. Imagine flipping a coin. While it's spinning in the air, it's neither heads nor tails, and it's both simultaneously. A qubit works the same way. It holds all possible values at once until you measure it. Now here's where it gets extraordinary. Quantum computers can also entangle qubits. When two qubits are entangled, the state of one instantly affects the other, no matter how far apart they are. Einstein called this spooky action at a distance. He thought it was absurd. It isn't. It's been proven in labs around the world. Entanglement lets quantum computers process information in a fundamentally different way. Instead of trying one path through a problem, a quantum computer explores all paths simultaneously. That keyring with more keys than atoms in the universe? A powerful enough quantum computer could find the right key not in billions of years, but in minutes. Here's the problem. Most of the security holding the internet together is based on one simple mathematical fact. Multiplying two large prime numbers together is easy, but reversing the process, figuring out which two primes were multiplied, is almost impossible. This is called RSA encryption. It protects your bank, your email, your medical records, every HTTPS website you've ever visited. A classical computer would need millions of years to crack RSA encryption with a large enough key. In 1994, a mathematician named Peter Shor published an algorithm, now called Shor's algorithm, that a quantum computer could use to crack RSA encryption exponentially faster. With a sufficiently powerful quantum computer, that million-year problem becomes a problem that takes hours or minutes. Every encrypted thing on the internet broken, and it gets worse. Intelligence agencies are already running what's called harvest and now decrypt later attacks, collecting encrypted data today, storing it, and waiting for quantum computers powerful enough to crack it. Your private communications from today could be readable in 10 years. So who's building these machines? Google claimed quantum supremacy in 2019. Their quantum processor solved a problem in 200 seconds that they said would take a classical supercomputer 10,000 years. IBM has a roadmap to build a 100,000 qubit machine. China has invested billions in quantum research. The race is on. But here's the thing. Current quantum computers are fragile. Qubits need to operate near absolute zero. colder than outer space. They're incredibly sensitive to vibration, heat, even cosmic rays. Keeping them stable, what physicists call maintaining coherence, is one of the hardest engineering problems humans have ever faced. We're not at the break the internet stage yet. Today's quantum computers have hundreds or thousands of qubits. Breaking RSA encryption might require millions of stable, error-corrected qubits. We're years away. But the direction is clear, and the defense is already being built. The National Institute of Standards and Technology, NIST, finalized the first post-quantum encryption standards in 2024, new algorithms designed specifically to resist quantum attacks. Google Chrome already uses one. Apple is rolling them out. The internet is quietly being upgraded before the quantum threat fully arrives. But the race is close, and not everyone will upgrade in time. Here's where we stand. Quantum computing is real. It's accelerating, and it will fundamentally change what's possible in computing, medicine, materials science, and cryptography. The same technology that could break every password could also simulate molecules at the quantum level, accelerating drug discovery by decades. It could optimize global supply chains, model climate change with perfect precision, and crack problems we haven't even defined yet. The question isn't whether quantum computing will change the world. It will. The question is whether we'll be ready for what it breaks before it breaks it. If this blew your mind, hit that like button. It genuinely helps this channel reach more people. And subscribe, because next we're covering something you use every day without realizing it. The algorithm that decides what you see, what you buy, and what you believe. See you there. See.